Glucose. What is it good for? Well, it powers an absolutely load of things, actually. In mammals, the bloodstream transports glucose to the cells in need of energy. In order to cross the membranous cellular threshold, however, the insulin hormone is produced by the pancreas and facilitates glucose's journey into the cell. Said cell can then convert the glucose into the energy or energy storage molecules it needs. Without insulin, sugars in the blood build up, which deprives organs of the energy they need and causes toxic effects. Those who lack efficiency in producing insulin or show signs of insulin resistance are commonly diagnosed with type 2 diabetes. Enter Ozempic, Wegovy and Mounjaro, which are drugs now almost as recognizable as Tylenol and Tums. They were first used in patients with type 2 diabetes, and more recently as apparently miraculous weight loss aids. But what does science actually know about them? Glucagon-like peptide-1 receptor agonists, better known as GLP-1s, were born out of an unlikely discovery involving Gila monsters, the largest and only venomous lizards in the US. Scientists found that a compound in these lizards' saliva could bind to GLP-1 cell receptors in the human body, which in turn promote insulin production. The first drug made from the lizard saliva was called exenatide and was licensed for use in type 2 diabetes. A few years down the line, the next generation, semaglutide, arrived, and it was semaglutide which is an active ingredient in both Ozempic and Wegovy. Whilst the drugs are still used for blood sugar management in people with type 2 diabetes to great effect, it became clear they could also be used as weight loss medications, resulting from reduced food consumption. Since obesity is a major driver of type 2 diabetes, the resulting weight loss made the drugs a double winner for diabetes fighting. Obesity is highly complex, and there are many factors that contribute to someone's weight and body composition, and it really can't all be narrowed down to simply what people are eating. But it's also true that diet has a role to play. People who have lost weight with the help of GLP-1s often talk about how the drugs allow them to focus less on food and consequently eat less. That's because these drugs literally decrease your appetite and slow down the emptying of the stomach. Though this lack of appetite can also be compounded by side effects like nausea and diarrhea. The frequency of these side effects, as well as the high cost of the medications and restrictions on prescribing, have been identified as factors that can discourage people from continuing to take the drugs, which may then result in weight regain. This hasn't stopped a thriving black market for the products as well as drugs touted as alternatives though. The World Health Organization is one among many authorities to warn of the dangers of counterfeit semaglutide, which can contain incorrect or undisclosed ingredients and come with considerable health risks. So it's not just about whether a GLP-1 would work for an individual on a pharmacological level, it's whether they can access it, can afford to continue taking it long term, and can withstand any side effects. But there's another aspect to consider, one science is only just starting to learn about. What are the long-term effects of GLP-1s? Some people are concerned that rapid, significant weight loss can have the knock-on effect of causing nutritional deficiencies and decrease lean muscle mass. The latter is a particular issue as people age because it puts them at greater risk of falls and physical disability. GLP-1 receptors also don't only exist in the digestive system. They're found in cells throughout the body. So it stands to reason that taking the drug does something else beyond what it was designed and approved to do. A large study attempted to assess the scope of off-target effects of GLP-1s by looking at 175 different health outcomes. The study confirmed that there's a risk of more serious issues, including paralysis of the stomach, inflammation of the colon, and pancreatitis. Other potential negative effects include sleep issues and an increased risk of kidney stones. However, the study authors stressed that it was observational, so it's impossible to tell from the data if any of the effects are a direct result of taking a GLP-1. For example, an increased risk of kidney stones could come from dehydration caused by lack of appetite, rather than an effect of the drug itself. But the picture painted by the study was not all negative. These drugs also appear to be associated with a range of health benefits, some of them surprising. One concern that's been raised repeatedly is whether taking a GLP-1 can increase the risk of cancer, particularly pancreatic cancer. However, a range of recent studies have found the opposite, that these drugs may actually protect against certain forms of cancer. On the pancreatic cancer question specifically, A study of over 540,000 adults found no support for an increased pancreatic cancer incident over 7 years following the start of a GLP-1 treatment, though the authors note that a longer follow-up study is still needed. In certain types of dementia involving the pathological protein tau, such as Alzheimer's, faulty processing of the stored glucose molecule glycogen could be at fault, which explains why GLP-1s might be a promising avenue to treat this condition too. The drugs also have the potential to treat the chronic inflammatory skin condition hidradenitis suppurativa, better known as HS. HS can cause excruciatingly painful lesions associated with the apocrine sweat glands. Higher body weight is considered to be among the risk factors for developing HS, so it's possible these drugs have an anti-inflammatory effect. The bottom line is that GLP-1s are still comparatively new, and they have not previously been used on this scale. And as such, there are a lot of open questions that scientists are actively researching. For now, the decision to start taking a GLP-1, as with any prescription medication, is one that should be taken under careful consideration of the known benefits and harms, and in collaboration with medical professionals.